Hi, everybody. I'm here today to talk to you about the Power Thermal Notification SDK. We have a great article on MS Docs if you go to aka.ms/power thermal notification. Most of the stuff I'm going to talk through today is covered there in a more dense format. Before we begin, just to talk a little bit about myself and also about Arthur, who helped contribute to this presentation. I am the principal engineering lead for the platform fundamentals and drivers team. That's a mouthful to basically mean that I do BSP bring up for devices like HoloLens. I'm also in charge of the group that looks at power, thermals, and performance. And because of that, I'm also in charge of the Power Thermal Notification SDK, which we recently deployed. Arthur Walaco is a principal software engineer at Mixed Reality Apps. He worked on the integration with Remote Assist, and he's going to be integrating the SDK into guides shortly. So a little bit about the agenda today. First, just some background about thermals and how they play into HoloLens. Then some about the SDK, what it is, how you get it, how you use it, how you can test your code. And then I'll close a little bit with talking about how Remote Assist has integrated this. So background about power, thermals, and performance. Well, the first thing to mention is that HoloLens is obviously a wearable device. And because of that, it's really crucial we're thinking about customer safety and comfort all the time. So this means that when we're thinking about comfort, we're also thinking about how much weight is on the head. And because of that, we minimize things like having active cooling devices such as fans. Also, thinking about HoloLens 2, we also want it to perform like at its max. We want it to do whatever we can, but this is closely related to power consumption and thermal dissipation. So there's a trade-off here between comfort, safety, and power. Pushing the system too hard will cause it to approach a safe operating condition, and it will force either the application to close or the HoloLens to shut down. So out of the box, HoloLens already has a bunch of features to help mitigate temperature situations. So there are many temperature sensors all over the device, and software mitigations start to kick in when the device gets warm. Just some examples of this are stopping mixed reality capture, as well as shutting down a foreground application. If the device continues to heat up, there's a software shutdown that can be activated. And if for some reason you're blowing past all of those things, there are hardware sensors on the device that will force it to shut off immediately if it crosses a safe boundary. So the big reason we have an SDK at all is even though we're doing all these things internally on the platform, there's nothing available to the application. And the idea here is that the developer and the application know a lot better what they're doing and what they're going to be able to throttle back to reduce performance in order to reduce heating, either because the application itself is running with a high workload, or maybe it's running with a lower workload, but in a higher ambient environment. So what is the SDK? Well, at the heart of it, it allows an application to subscribe to thermal notification events and implement its own custom mitigations. And in some cases, we'll even allow the application to, replace the mitigations in the system. In other words, they can suppress them so that the system doesn't do what it normally would do. It also allows developers to monitor how quickly the device may be heating up or cooling down. Here's just a screenshot of one of the UIs that's being presented for Remote Assist, just to show you this is kind of what it might look like if I wanted to show the user, hey, my device is heating up. And from an application standpoint, now you can do that. So diving a little bit more into the details about the SDK, the first thing I'd like to mention is that it's device agnostic. The idea is that this could be used on the next mixed reality device. Your code doesn't have to change. It will just work. So how we do that, we abstract information about absolute temperature and temperature sensor locations to make this portable across devices. There's no temperature sensors. Instead, we have the notion of a peripheral like a CPU, battery, or display. And then instead of absolute temperatures, we talk about levels, which I'll go into detail later, or enumerated values for certain events. So here I've shown just like at a high level like what this might mean. So maybe you have two temperature sensors going into in proximity of the display, and we can aggregate that information, and maybe one temperature sensor for the CPU and two for the battery. You'll notice here I put the CPU and the battery closer together. Sometimes the temperature sensors, we have multiple of them in an area, but they're so close between the peripherals that the information they're providing is effectively the same. We'll talk about that later when we dive more into the details of the SDK itself. So I talked about subscribing to notifications. This allows an application to monitor what we call a mitigation level, and it's attached to a peripheral. And as I said earlier, in many cases, the application developer has a better idea of what they can do to mitigate than the system. And they do this in a reaction. And then the other concept here is a thermal score that can be monitored by peripheral. And this provides a linear range that can be used by the application or even in testing to understand how fast the device is heating up or cooling down. And then again, suppression of some mitigation. So at the bottom left over here, this is copied from our article. We have a list of what the system currently does to suppress things, at which mitigation levels they suppress things. And you can use the SDK to say, hey, I actually want to be suppressing any actions that are associated with the GPU, and these would be the actions that would be suppressed. Okay, all that out of the way. The first most important thing is how do I get it? And what forms does it come in? So it comes in two forms. You can get it for Unity through the Mixed Reality Feature Tool. Hopefully you've seen this in a couple places already today. You get the tool, you open your project, there's a special box shown right here. Just to click for the SDK, boom, you're done, it's in the project. The other way to get this is if you're using C# or CPP, but it's not through Unity, we have a NuGet package, and that's at aka.ms/powerthermalNuGet package, PKG. And the reason that we chose to ship it this way as opposed to built into the OS is because we can provide updates to developers out of band from our OS releases whenever we need to. Just a little bit about how it's deployed and what it kind of looks like. It comes with two pieces. One is a projection, which is like C# that your application calls into, and then that tunnels down into a native binary called an ABI, Application Binary Interface. And those both get deployed onto the device with your application in order for this to work. Okay, so now we're going to start talking about the different building blocks that make up the SDK and how they relate to each other before we talk about any function calls or properties, stuff like that. So the first is mitigation level, or more formally, power thermal mitigation level. This is that enumerated value, and it tells you how severe the temperature is in terms of what kind of mitigation should be applied. So this starts from no user impact, which means like you're in an optimal condition, or if you had a higher impact before, it means, okay, we're in a safe place, you can release the mitigation you were doing and go back to an optimal condition. And that goes all the way up, minimum, medium, and maximum user impact, where maximum user impact means, look, if you don't do something pretty strong soon, your application is going to get shut down by the system because we're just running too hot. Another thing that's worth mentioning right now is hysteresis. So what this means is we have some special logic in the reporting of these notifications so that if you're right on a boundary of temperature, you're not going to just see the mitigation toggle back and forth, back and forth. So instead, the way this works is you will see the level only rise. So mitigation level 0, 1, 2, 3. If the temperature starts decreasing, it's not going to go back down until we get to the safe condition and actually just a little bit below it to provide some more hysteresis between level 0 and level 1. And I'll go through a diagram that details this in a minute. So that was the mitigation level. The other important building block here is the thermal score. So instead of an enumeration, this is correlated with a range from 100 to 0, where 100 is a nominal condition that you'll see as the temperature goes from a low temperature all the way up to right where we're starting to like pay really close attention to what's going on in the system. And then you'll see it linearly drop down to 0. 0 coincides with the temperature that the system is automatically going to close your application. So you'll never actually see 0. You'll get close, and then your application goes away. The thermal score is useful for understanding what the system is doing more than implementing a mitigation, unless you're just feeling very adventurous. So you can use this, for example, to run your application in the environment you think it's going to run in and monitor the thermal score to see how it's reacting, and then deploy a different version with your mitigations and make sure that the reaction has changed the way that you expected. So let me pull up my handy dandy laser pointer here. Here's that visual I was talking about. On the x-axis here is temperature, and then on the y-axis we have the mitigation level. So as the temperature starts lower, you're just reporting level 0 for the peripherals, and at some point there's some start mitigation set point we have for the temperatures of that peripheral. Again, remember, there's multiple sensors involved here, so it's not a specific temperature necessarily. And once you cross that, we'll start reporting level 1 to the application. And assuming you keep heating up, we'll go to level 2, level 3. Now, if the temperature comes down and we go back into that 2 boundary, remember there's this hysteresis, which means we're still going to be reporting 3, still reporting 3. And then even here, where that first boundary was crossed, we'll still report 3 until we get right there at this release stage. And the reason for that is if we're flirting with this temperature point here, we don't want to go 0, 1, 0, 1, 0, 1. So it'll go to 1, it'll come back down, and it has to cross this lower boundary to go all the way to 0 again. Then on the bottom, we talk about thermal score. So this is that linear range, and it starts lower in temperature than the mitigations that are being reported. And it'll start from 100 and go all the way down again to 0 where the application is shut down. And then you can see here, if the temperature keeps increasing, we have a software and a hardware shutdown. So just to beat it in one more time, there's two main concepts here. There's thermal score and mitigation level. And the idea of the thermal score is that you have information available prior to the mitigation level notifications. It has more resolution than the mitigation level because it's going from 100 to 0. It doesn't have any hysteresis, so you can track those ups and downs a lot better. And for this reason, it's suggested for understanding the system before and after, as opposed to looking at the mitigation level where you have 4 unique 0, 1, 2, 3 levels that are attuned for the application to have time to take a mitigation and the system to respond. That has hysteresis built in, again, so you won't be going back and forth. And this is what we're suggesting you use to trigger an actual mitigation or UI or whatever you're going to trigger. Okay, so those are the two reporting mechanisms. The other thing to talk about is this notion of power thermal peripheral flags. I mentioned we are talking about peripherals here and not temperature sensors. So this is how you describe that to the SDK. And they can be bitwise combined because each peripheral is a single bit. So sometimes you may be interested in one thing, sometimes you may be interested in 2 things, sometimes you may be notified about 3 things. And the mask of these things tells you what we're talking about. Okay, all that out of the way. The first thing to mention about actually using the SDK is it's a singleton for the process. So you can't have 2 of these operating within a process. If you do that, it's going to be operating on the same thing, and you're going to see some strange behaviors. So to get the instance, you call this getForCurrentProcess function, returns the instance, and then you may or may not want to check if there's actual support on device for either the SDK as a whole or the peripherals that you're monitoring. I think all the peripherals we've defined now are in HoloLens 2 as it is today, but in the future there's a possibility where there is a peripheral that is or isn't supported on a different device, and this is a mechanism to understand that. So you provide it a mask of all the flags that you're interested in seeing if there's support for, and this will return true if there's support for at least one of those flags. So let's say I'm interested in the CPU and the GPU. I can OR those together. I can send it to this function. If it returns true, I can expect that I'm going to be able to get notifications for at least one of those things. Okay, so peripherals of interest. This is a property in the class, and you set this with a mask of the peripherals you're interested in. In a second, I'm going to talk about the two ways you actually get the information about thermal score and mitigation level. Both of those require you to set this field with the peripherals you're interested in. And if you don't, either you're not going to get notifications or you might get exceptions. So there's two ways to get this information. There's an event-based approach and there's a polling-based approach. So we'll talk about event-based first. Being event-based, you may be interested how frequently you're going to get events. It's on the order of seconds or multiple seconds or even never if you don't even get into that range. There are two events that you have the option to register for. You can use one, the other, or both. One is power thermal mitigation level changed, and one is power thermal score changed. One is for the mitigation level, one is for the thermal score. Each event comes with some arguments that are bundled together. One tells you what the event is talking about, and this is the impacted peripherals. So you look at that, it may be one or more peripherals, and those are associated with a mitigation level or a thermal score that's being reported. Again, there's two events, so I say or. It depends on which event you're using. So this is an example of event-based usage. Here is where we grab the instance of the class. We create a mask of power thermal peripheral flags by ORing the CPU and the photo video camera together. There's a check here for support based on those flags. I will mention, because I haven't mentioned it yet, you don't have to do this check. If there isn't support for the SDK, it's not going to blow up. It's just not going to give you notifications, or if you're polling, which we'll talk about in a minute, you're just going to get some nominal numbers that look like everything's fine. But you can check. So if, in this case, we're checking and assuming that it's supported, we'll set those peripherals of interest with that mask. We'll register the notification handler. And then when an event fires, it'll come into here. And we're going to check the flags to see what the event is related to. So here, we'll check for the CPU. And if the mitigation level is 0, we're basically going to clear a throttle flag. And if it's greater than 0, we're going to set a throttle flag. It's also useful, I think, to point out here that this is an if, not an else if, because again, you might get two things together here. So first, you might have to process the CPU, and then you might have to process the photo video camera. So that was event-based. If you're going to use polling, there's a function called getLastPeripheralState, and you pass it a single bit from that peripheral flag's mask. If you pass it 2 bits, or you pass it a bit that wasn't in that impacted peripherals, peripherals of interest property that we talked about earlier, you're going to get an exception. So yeah, you pass it the bit, and it returns this structure, power thermal peripheral state. It has a thermal score and a mitigation level that are provided to you. We've talked about those, I think, in plenty of detail. It also has this is supported peripheral field. So the idea here is you may have not checked for support, or you checked for support with a range of different peripherals. You're now asking for a specific peripheral, and you don't know if that specific peripheral is actually supported by the SDK. This will tell you yes it is or no it isn't, in case maybe you had some backup mitigation plan if that particular peripheral wasn't supported in the SDK. This is an example that is from the mixed reality feature tool deployment sample that's built in. I'm not a Unity guy, so forgive me how this looks, but we register here with the peripherals of interest for a monitored peripheral, which can be set within the editor. And then when update is called, we basically check the timestamp to see if enough time has passed that we want to poll again through the SDK. We grab the state by doing a poll for that monitored peripheral. and then we pass the thermal score and the mitigation level to some helper functions to do some work with them. I mentioned before that you can suppress some things that the platform is going to do. The way to do that is either to use this property, here's another mouthful, suppress platform mitigations for peripherals. So you just set that with the mask of the platform mitigations associated with a given peripheral that you want to suppress. So for example, if you use that with the display peripheral, it's going to suppress any depth frame per second reduction. There's also a method which does the same thing, but in this case, you don't have to do a read and a write. If you're just trying to change some bits of the property, you can provide the flags that you're interested in and whether you want to set them or clear them. And it'll just do that all under the hood. There's one important thing to mention here if you are going to use this, which is that your process has to be in the 3D foreground for the system to honor this suppression request. We're not going to let anybody who has some process running in the background like hijack the system and allow them to suppress peripherals. It has to be something in front of the user's face. The suppression example is pretty simple. Grabs the instance, sets the field, and this is just setting the field again using the function with the true or the false. Okay, so once you've hooked into the SDK, what are the test hooks? So in the device portal, which I don't know if you're all familiar with it or not, but if you connect your HoloLens and open up Edge or whatever browser, you can go to an IP address if you're in developer mode, and you can see something like this. So in the device portal and through REST APIs that are exposed in developer mode, you can both control the mitigation level and monitor it, and the thermal score. So what this means here is I have these rows. These are by peripheral. I don't know how well that shows. Yes. By peripheral, and then next to that it shows what the current mitigation level is for those peripherals. Then we have control buttons to change the mitigation level being reported throughout the system. So if you click increase, it's going to send messages both to the platform and to applications that are subscribing the SDK that the level has changed, and you should see this propagate throughout your app. You can do the same thing with the thermal score by dragging these sliders. So that's control. In terms of monitoring, if you're not monkeying with these sliders and you're just watching this page, these are going to update in real time with what the system is doing. So as the system actually heats up, you'll see the thermal scores start to drop by the peripherals, and you'll also see the mitigation levels change. Remember back at the beginning when I told you sometimes peripherals are close together and you see things change with the same kind of information? So either when you're monitoring or you're playing with these buttons, you're going to notice on HoloLens that the CPU and the GPU are closely coupled. If you change the CPU with the button, you're going to see the GPU also change. And the reason is that. Video. So here's, sorry. Working. Here's a video of, can you all see that? Is that big enough? Okay. Here's a video where over here we have a sample app I've made with UWP, and in the background is the device portal page. And you're going to see on the right side, I'm going to click those buttons, which increase the levels for the peripherals. And on the left-hand side, my application that's using the SDK is going to respond. They're kind of in similar format by rows of peripheral and then mitigation level and thermal score. So you'll see me click, I think the thermal score first, dragging the slider. You'll see the numbers change. I'll do that a couple times, then you'll see the mitigation level change, and that'll be reflected as well. Okay, so I just changed the slider and it dropped to 48 on the CPU. And you can see the other peripheral change as well. And then here, just changing the mitigation level with the buttons. Okay, let's try to jump back to where we were. Oh, now the video works. Great. Anyways, we also have a Unity sample, I think I mentioned, that's deployed with the Mixed Reality Feature Tool package. I don't want to dig too much into what that does, just talk about the basic building blocks that it has. It has this mitigation score updater class, which is in charge of just updating like the colors of a cube or the text of a label to indicate either the thermal score or the mitigation level. We have a polling component, which you put it on an object and it will poll, and a notification component that also leverages a notification manager. There's this extra manager because we have a single event registration and it dispatches it to different notification components. The cool thing with doing this in Unity, again, not a Unity person, is that in the editor, you can just assign peripherals that you want to monitor on the object. I can associate these with the text that's above them, and this is a polling component, so I can set the update interval in seconds. And then this other guy over here is a notification component. So same idea, I can pick a peripheral that it's going to monitor. I can pick this text box that it's associated with. And then also, if you want to see how the suppression is built in, there's a box to say, hey, this is a peripheral I want to suppress. Also, now that I mention it, I don't think I said it. In the device portal on that SDK page at the bottom, there's a little place that'll tell you what's being suppressed. If you want to make sure that your requests are being honored, you can have that up while your app is running, and you should see the peripherals that are being suppressed show up there. Here's my little example video, similar to the UWP app I showed before. A couple things to point out before we do this. One is that, remember, the guy on the left here is polling, the guy on the right is event-based. And because of that, you're going to see these two are also peripherals that are in close proximity and get the information at the same time. Same information. You're going to notice that the block over here is updated before the block over here because this has that polling delay. And then the other thing to mention is just that you're going to see the colors and the numbers change like asynchronously. Like in the real world, if your device is heating up and you're not using the device portal to test this, they're going to be correlated. This is where I'm monkeying with those two things independently, so they change independently. So I'm changing the slider in the background. And you'll see the CPU thermal scores changing at the top. And then the mitigation level, which is the color, is changing. And again, you see that delay because the event is coming in much quicker than the polling. So that was a lot of information about like what we're doing and why we're doing, what the SDK is doing, why we're doing it. But like you may be thinking, and this is like, I think this is probably the most important slide of the whole thing. What should I do? So this is just copied straight from that article that I pointed to at the beginning. But this is a list of things by peripheral that we recommend that you look at doing if you want to try to throttle back when you're getting these mitigations. Okay, switching gears here just to talk a little bit about how we've integrated this with Remote Assist. So both the OS update that supports the SDK and the Remote Assist version that supports it both went out in April. We're going to talk about just a little bit about what Remote Assist is in case people aren't familiar with it. The steps we went through to figure out whether we can actually do anything here and what we should do. And then kind of what we did and how we provided feedback to the user and the results that came out of that. So what is Remote Assist? There's two versions. One is for mobile and one is for HoloLens, and this is specifically going to be talking about HoloLens. And the idea is it enables connection with a remote collaborator over Teams. So you have one person, let me turn on my little laser again. You have one person who maybe is doing some work looking at a control panel, for instance, and he's in this Teams call with another person who can, up at the top, see what is being seen by the HoloLens, and they can also annotate in real time what that person's seeing. So this guy is inking up these wires over here. The guy at the bottom is going to see that inking on his visor. You can also do arrows, object-based annotation with these arrows. Same idea. You can also do file sharing in case you need to pull up a document or something. And as you can imagine, doing these things fluxes the full capabilities of the device, and that results in higher power and warmer devices. So the first thing that we did was to figure out, can we mitigate anything, and what levers actually we can pull that will work well. So there was this data-backed investigation where the remote assist team was changing things like playing with the incoming video stream, the outgoing video stream, the resolutions and frame rates of the outgoing video streams, looking at the power in all these cases. And you can see on the right this relative power savings by changing either the resolution of the outgoing camera or the frame rate of the outgoing camera. And that gave us, I don't show it here, but the incoming camera, we didn't see any effect. And so that gave us some findings that, okay, the incoming camera, trivial impact, the outgoing camera, there's some things we can do here. There's a lot of different choices. We narrowed it down to 3 things because of how many different enumerated values we're going to get from mitigation level. And those were lowering the frame rate, lowering the resolution, and disabling the outgoing video entirely as a last resort effort before the application is closed. Now, I think it goes without saying, but I'm going to say it anyway. We're trying to maximize the user's experience as long as we can at the expense of some degradations, right? So we want to do these in order of what is least going to impact the experience here. So we start with the little things like the frame rate, and then we move to bigger things like the resolution, and then we go for the big hammer to cut the power, to cut the video. So this kind of outlines the actual resolution and frame rates that we changed, and how we did it. There's a media layer that is taking some input from a JSON, and we can set the maximum frame rate and the maximum resolution that's going to be used. There's some other things that feed into this, so it actually can throttle down even more, but we set the maximums based on these mitigation levels. And then there was also some logic built in to deal with video restarts. So an example of what this means and why this matters is, just like Teams, when you're on remote assist, you have the option to turn off your video camera. If your video camera is off and then the device gets hot, we don't want the video camera to turn on at a lower resolution than it would have been on if it was on the whole time, because you didn't expect the camera to be on. And similarly, if your video camera was off and we get to a high mitigation level, high enough that we can't have the camera on at all, and you try to turn on the camera, we shouldn't let you turn on the camera. We want to say, hey, no, we're not going to let you do that, but there's a reason we're not going to let you do that, and that's because your device is pretty hot right now. And then I'm going to jump ahead and come back. So here's an example here where the outgoing video is unavailable. This is feedback to the user that they would get in that particular case. And then here at the bottom right is, this was implemented in a scriptable object in Unity. So within the editor, that allowed pretty fast iterations on changing how these things were going to kick in and at what different mitigation levels. And they're all just set by changing some menu items here. Also worth mentioning is that I mentioned the device portal interface for testing, but that requires you to deploy all the way to the HoloLens, which with Unity can take a bit of time, and then do your test. And then if it doesn't work, you're going to have to do that whole process again. So as part of this, the Remote Assist team built some Unity editor tooling to basically mimic what the device portal is doing and showing. That's shown down here, and that allowed them to do a lot of their testing inside the editor without having to actually deploy to the HoloLens first. This is just to talk about feedback considerations for the user in Remote Assist. We talked about this one here where the camera can't be turned on because it's too hot. But if the camera was on, for example, and it's starting to heat up, it'll tell you, hey, we've reduced your video quality, or hey, we need to shut off your camera right now. So this is the end-to-end is this video going to play? Okay. There we go. This is the end-to-end example of the Remote Assist integration, and what you're looking at is actually Teams showing what Arthur, who's in there, is looking at. He's going to be monkeying with the buttons on the left, and you'll see there's a window on the right where he's highlighting the resolution and the frame rates of the video feeds as things change. So here's 15 frames per second at 720. He's going to increase the level again. There's a flicker because the video has to go on and off in order to do this. He'll pull up the debug window here again, and now we're at 360 at 15 frames per second. And then the last time he does this, we're going to do that heavy hammer. It's just going to shut off the video entirely that's incoming. Then he's going to reset it, and you'll see everything will come back to normal. And then there's a nice little message that says, hey, your device is cooled down. We can turn everything back on. So we took some results using the device portal to force the different mitigation levels while running the app, just to make sure that they were in line with the power reductions that we had observed independently. And they are. It's very close. It's actually, you'll see in this particular case, it's actually a little better than we expected. And this reduction in power directly influences how much thermal dissipation there is and how long the device can operate at a given ambient condition. And the plan is to integrate this into guides next. So here's the link that I mentioned at the beginning. There's a great article with basically everything I've talked about here, plus like details on how to use the REST APIs if you dig down into the links. So aka.ms/power thermal notification. All right, at this time I'll turn it over for questions, and I think we're going to pass the mic around. I'm running.
Thank you so much. Hey, thanks for the presentation. I just have two questions. The first one, or actually it's one question, but regarding 2 points. The first one is, what about Bluetooth connected devices? Is that covered as part of any of the peripherals that impact the thermal score? And what about wireless casting as well? Is this covered within those peripherals?
I think the answer is no, but like, can you elaborate on, like, maybe I don't think I fully understand the question.
So I have some customers who are actually using applications that are relying on Bluetooth connected devices for the to the HoloLens.
Okay.
Like some stuff like a stethoscope, for example, for some medical scenarios and so on. Is this something that is covered as part of the peripherals that are impacting the thermal score today?
We tried to make the peripherals pretty generalized, and I think it's called like networking.
Yeah.
So that's what I would monitor then.
I saw the networking is covering Wi-Fi connections and Ethernets, but will this include Bluetooth as well?
Right. So in a lot of cases, we have lots of temperature sensors, but they're like certain areas of the device where we can get a good feel of if it's heating up independent of other things. Right. And so like we don't have that granularity to say Bluetooth or Wi-Fi. Or...
okay. So it's overall in general.
Yeah.
And the same applies for wireless casting as well, right?
Yes.
Yeah, okay. Thanks a lot.
Thank you for the presentation.
Sure.
Is there a way to control the resolution of the HoloLens or maybe the CPU power of the HoloLens from Unity?
From Unity?
Yeah.
I don't have the answer for that for you today. I'm not a Unity guy.
Or from, from a UWP app. But what I'm saying is basically control the resolution of the HoloLens. Maybe it reduces maybe the CPU goes to 75% or
So-
60% or something like
As
that?
of today, I know for a fact you cannot change the CPU. That's been put in place to basically ensure a fixed user experience given some conditions. Resolution. You're talking about display resolution?
Yeah, like if you could possibly reduce the
Yeah, so
sort of
I'm
power usage.
These are
and the
this is our
power-
like official like recommendations that went through several teams beyond myself. But like, so here's what we recommend for display. You can see it doesn't like include the resolution right now. So probably not.
All right, that'd be a great feature though if we could like reduce the CPU that the app is using. Not reduce the CPU that the whole HoloLens is using, but yeah, that'd be great in the future. Thank you.
Yep. Anybody else? All right. Thank you.